Welcome to CIVIL-MECH-MATHS CONCEPTS channel. It is run by me. I am an IITian. I would like to start a course in competitive aptitude for CAT examination, GRE examination and GMAT examination. And I want to start today on the subject of number system and algebra. Today in this lecture I want to give a small brief of reminder theorems, how they will be useful for you in solving certain questions in competitive examinations like CAT, GRE, GMAT. Especially in quantitative ability and quantitative aptitude questions. Now, let's go in detail. Let's take a question so that I will solve and give the clear concepts. I will solve a question and give the clear concepts so that those concepts you try to observe and apply in the examination. The concepts are the must. Let us try to find out. Find the remainder when 10 to the power of 2025 is divided by 7. Let us go for the solution. This is the only first introductory lecture. I want to go with some example. From next lecture onwards, I will be going on the theory, in the number theory and also in algebra, so that you will get the clear concepts and you will understand the concepts well. This question involves number theory, modular arithmetic, and in number theory, it talks about Fermat's little theorem. In this first lecture, I just want to, through an example, I just want to appreciate the value of the theorems in number theory. There are many theorems in number theory and algebra. Once we understand the concepts of this number theory and algebra theorems, then we will be able to apply them and solve any question. But we have to understand clearly the concepts and apply them in the examination properly. Now, here, what is the concept we are going to develop and understand and we are going to apply in this problem? In number theory, Fermat's little theorem. What this Fermat's little theorem states, that if a is an integer, let a is equal to integer, p is equal to a prime number. I think prime number you may be knowing. A prime number is a number which cannot be divisible by any other number except the number itself and 1. That is called as the prime number. Let p be a prime number and a is an integer. Then little Fermat theorem says a to the power of p minus 1 equivalent 1 mod p. What is its meaning? We have to understand its meaning, because to solve it from the face value of the problem, to get the value of 10 to the power of 2025 is not that easy. And then we have to divide it by 7. That means we require some specific knowledge in the number theory theorems so that we can answer this particular question. Now, here P is a prime number. Please tell me whether 7 is a prime number or not. Here I am going slow so that it is the first lecture. I want you to appreciate the remainder theorems in number theory so that you can solve the problems with ease. Here P is equal to prime number and let it be 7. 7 is a prime number, because ultimately what we wanted, 10 to the power of 2025 should be divided by 7, so that we want to find out the remainder. Then P prime number is 7. Then from the given equation, from the given problem, 10 to the power of 2025. This is in the form of a to the power of some number that means, can I say a is equal to some integer? I am just only correlating Fermat's theorem with the numbers whatever are given. 10 to the power of 2025 is given to me. Hence, I am thinking 10 to the power of 2025 is something like it can be represented in a to the power of n, where n is equal to 2025 and a is an integer 10. 10 is an integer. Then, from Fermat theorem, how can I represent this? A is 10, P is prime number 7, 7 minus 1, P minus 1, equivalent to 1 modulo P is 7. This is what I have written. Now I have to decipher what it means. This is equivalent to 10 to the power of 6 equivalent 1 modulo 7. What is its meaning? What it means in modular arithmetic. Or what it means. This mod 7 is nothing but modulo 7. It is equivalent, it is not is equal to, it is equivalent. 10 to the power of 6 equivalent 1 modulo 7 means 10 to the power of 6 minus 1 is divisible by 7, or it can also be interpreted as when 10 to the power of 6 is divided by 7, remainder is equal to 1. Please try to understand, it is a very important concept as far as number theory. It is regularly used in number theory in various applications. 10 to the power of 6 equivalent 1 modulo 7, 1 mod 7 means this is any value. This is remainder. Sorry, spelling of remainder is remainder. 7 is 10 to the power of 6 is divided by 7. Division. The prime that divides the given number. When this prime 7 divides the given number 10 to the power of 6, there is a remainder 1. Now, what is asked? Now, question is, the given question, what is the remainder when 10 to the power of 2025 is divided by 7. So that in the modular arithmetic form, how we can write? Ten to the power of 2025 equivalent to, what is the remainder? We don't know. Modulo 7. That means 10 to the power of 2025 when divided by 7, what will be the remainder? That we have to find out. Now, we try to apply now Fermat's theorem. As per Fermat's theorem, as per Fermat's little theorem, lecture may be going for longer duration. Please don't mind, because it is the first lecture from my side on quantitative aptitude for CAT, GRE and GMAT. I want to be little bit illustrative and try to make the theorem understandable for everybody. Now, as per Fermat's little theorem, it is given that 10 to the power of 6 is equivalent to 1 mod 7. Our given question is 10 to the power of 2025 equivalent to what remainder? Mod 7. This is what we have to find out in red color. And what we know is, this is what we know from the Fermat's little theorem. Now, 10 to the power of 2025, can we convert it into 10 to the power of 6 forms? Let us try to convert this into some form of 10 to the power of 6. Now, 2025 is nothing but 6 into 337 plus 3. Do you agree? Yes. Let us divide 2025 by 6. How it came? 2025 divided, because here 10 to the power of 6, here it is 10 to the power of 2025. When you divide 2025 by 6, it will be 337 plus 3 remainder. It is the remainder. Don't write it as 337 plus 3 as 340. No. 337 is the coefficient 6 into 337 plus 3. Now, when 2025 is replaced by 6 into 337 plus 3, let us see what happens. Now, 10 to the power of 2025, how I can write? 10 to the power of 6 into 337 plus 3. Can I write like this? Yes, we can easily write. Then how it will be? When number x to the power of a into b, that is nothing but x to the power of a to the power of b. Then can we write 10 to the power of 6 into 337 as 10 to the power of 6 whole to the power of 337 into 10 to the power of 3, because x into a, x to the power of a into x to the power of b is equal to x to the power of a plus b. When there is a summation in exponential, that will be converted in the normal sense, that will be converted to multiplication. Please remember these exponential properties of any number. By applying these exponential properties, what we are getting here? Ten to the power of 2025 is equal to 10 to the power of 6 to the power of 337 into 10 cube. Now, we already know 10 to the power of 6 is equivalent to 1 modulo 7. Then 10 to the power of 6 to the power of 337, how we can write? Ten to the power of 6 to the power of 337 is equivalent to 1 to the power of 337 modulo 7. That implies, because it's a very crucial step, please try to understand this. 10 to the power of 6 to the power of 337, what I made? Here remainder is 1, 1 to the power of 337 mod 7 mod 7, that remains the same. What is the value of 1 to the power of n? Any value n, that is 1 only. Then here whatever I am writing on side, it is a concept. On the basis of this concept, we got this result. 10 to the power of 6 to the power of 337 equivalent to 1. 1 to the power of 337 is 1 modulo 7. But what we are supposed to know? We are supposed to know 10 to the power of 225. 10 to the power of 225 is nothing but 10 to the power of 6 to the power of 337 into 10 cube. Hence, 10 to the power of 225, how can I write? 10 to the power of 2025, sorry, not 225, it is 2025, equivalent to this 1 into 10 cube is 10 cube. 1 into 10 cube mod 7. Please see this. This step is also very crucial. This step has come from this step. We are simplifying. Now, what is the next step? This can be written as 10 to the power of 2025 modulo equivalent to 1000 mod 7. What is 1000? Let us concentrate on the right hand side. Now, 10,000 mod 7 is equal to how much? Once we know that, we can find out the remainder. What is 1000 divided by 7? Because from this we can understand that when 10 to the power of 2025 is divided by 7, there is a remainder is 1000. But remainder it cannot be 1000. 1000 is still divisible by 7. When 1000 is divisible by 7, 1000 by 7 is equal to 142 into 7 plus some remainder. What is that remainder? Remainder is 6. This is remainder. That means we can write 10 to the power of 2025 is equivalent to remainder 6 mod 7. Instead of 1000 I am writing 6 mod 7. Remainder is 6. Because 1000 is equivalent to 6 mod 7. Because 1000 when divided by 7, the remainder is 6. Hence, 1000 is equal to 6 mod 7. 10 to the power of 2025 is equal to 6 mod 7. This is the final answer. We have not done massive calculations, massive divisions. With the Fermat-Little theorem, we got that the remainder is final remainder when 10 to the power of 2025 divided by 7 is equal to 6. This is the answer. Either whether it is to be typed answer without any alternatives, if alternative is given, you can easily say that 6 is the correct answer. And as a homework, please take this. Find the remainder when 10 to the power of 1000 is divided by 7. Please take it as a homework for practice and ensure that you apply the Fermat's Little theorem in the way I have explained you and solve this particular question. And if this type of questions do come in your examination, you will be able to solve very easily. You can even take another example also as a homework. Find the remainder when 29 to the power of 2025 is divided by 7. Remainder is how much? You can have multiple questions in your hands once you know the theorem. The concept is apply the Fermat's theorem. Fermat's theorem says a to the power of p minus 1 is equivalent to 1 modulo p. This is the Fermat's Little theorem. This is the Fermat's Little theorem. We applied this and got the answer as remainder as 6 when 10 to the power of 2025 is divided by 7. This is a type of modular arithmetic where we can apply the theorems and get the answers. When we try to do physically, manually the questions, we will not get it without using any theorems in number theory. We can get the answer, but it will be a very lengthy process. We require practicability and in less time how fast we can answer the question. That is the prime requirement for scoring high in the quantitative aptitude in the competitive examinations like CAT exam, GRE exam or GMAT exam. This is only a starting lecture and this is only a simple example. Like this, I will be teaching you one by one. I will start with modular arithmetic, then I explain you what is the number system, different types of number systems, and how to proceed in the number system to solve the problems that we come across in the number system and algebra, and we dwell upon different numerals, different examples, different problems, and we try to solve them. This is one part of the syllabus of GRE, GMAT and CAT. We will be moving forward to geometry and other topics along with this. Once we have started the journey, we try to complete the syllabus. We may not be able to complete the whole syllabus because syllabus for competitive examinations will be not disclosed fully, will not be complete. In any subject, syllabus is infinite. We try to find the maximum possible permutations and combinations where we can say that we are confident to solve this type of problems. Best of luck to everybody. Thank you for listening to me. I am an IITian and I started the CIVIL-MECH-MATHS CONCEPTS channel with a view to give the concepts in engineering and mathematics. There are many engineering mathematics lectures already available in this channel. There are many civil engineering and mechanical engineering practical problems already solved from this channel. Now I have started, in addition to engineering mathematics, I want to give insights and concepts for quantitative aptitude and quantitative ability for various competitive examinations like GATE, CAT, GRE and GMAT. Best of luck to everybody. Thank you for listening to me. My channel name is CIVIL-MECH-MATHS CONCEPTS. Let us move together and try to solve the problems in mathematics with clarity on the concepts. Mathematics is one of the subjects in which this channel is dealing with engineering mathematics and quantitative aptitude. Please, if you feel there is a value addition because of this video to you, kindly share this video and share my channel details to known people of you. Share and subscribe to my channel. Thank you. Best of luck to you in your examinations.